Hello guys, good morning. So now we will have a paper discussion session of the part test 14 chemistry paper. So this session is done by me. I am Shreyanka. So I am a chemistry faculty in Nine Education. So I am from IIT Kanpur. So okay, we will do the questions one by one. Okay, let us start with the first question. So in the first question, the photoelectric emission is observed from a surface of frequencies mu1 and mu2 of the incident radiation mu1 greater than mu2. If maximum kinetic energies of the photoelectrons is 1 is to k, then threshold frequency is given by. So let us write down the equations. There will be two equations which can be found by us. The two equations are like this. If you remember the photoelectric effect equation, it is nothing but incident light radiation energy H mu is equal to H mu naught plus kinetic energy, that is half mv square. That is what is photoelectric effect equation. So here there are two things happening. That means two frequencies of light are called as incident radiation. That means h mu 1 is equal to h mu naught plus ke1. Okay, ke1. And second equation is h mu 2 is equal to h mu naught plus kinetic energy 2. So on the same metal, okay, on the same metal, two types of light are incident on the same type of metal. So the metal threshold frequency won't change, whereas the light incident radiation frequency will change and kinetic energy, both of them will change. So these are the equation 1 and equation 2. So from here, let us just rearrange these equations like this. Equation 1 can be rearranged as h mu 1 minus h mu naught is equal to ke1 and h mu 2 minus h mu naught is equal to ke2. And these are the updated equations 1 and 2. Let us do the equation 1 by equation 2. We will get the formula or the result as h mu 1 minus h mu naught by h mu 2 minus h mu naught is equal to ke1 by ke2, which is nothing but he has given in the equation it is 1 is to k. So here the h will get cancelled. That means mu 1 minus mu 2 divided by mu 2 minus mu naught is equal to 1 by k. Now solve for mu naught here. Okay, solve for mu naught. If you solve for mu naught, k mu 1 minus k mu naught is equal to mu 2 minus mu naught. From here, we get it as k mu 1 minus mu 2 is equal to k minus 1 into mu naught. So here, mu naught is equal to k mu 1 minus mu 2 divided by k minus 1 will be the answer. So answer is nothing but option D. That is the answer for this question. So now let us move on to the next question. The second question here is about quantum numbers. Number of electrons present in different type of subshells, and different type of orbitals. We need to just recognize what type of orbitals are these. The question number, bit number A is nothing but n is equal to 4 and l is equal to 1. It's nothing but 4p. 4p, you know that for p contains max electrons in p subshell is nothing but it is 6. So the answer would be first for this, it is 6 electrons. It is 6 electrons in A. Then in the same manner in B, n is equal to 2, L is equal to 1. That means 2p. That too, magnetic quantum number is mentioned and spin is mentioned. You know that only one type of electron contains all set of quantum numbers and no two electrons will contain the same set of quantum number. So since all quantum numbers are mentioned, these quantum numbers are only depicting one electron. So that means for the second bit, only one electron will have all these set of quantum numbers. Next, n is equal to 3. N is equal to 3. What type of subshells are possible? 3s, 3p, and 3d. 3s, 3p, and 3d. And in S subshell, how many electrons are possible? Maximum 2 electrons. In P subshell, 6 electrons are possible. In the same manner, in D subshell, 10 electrons are possible. Total electrons possible in the third subshell is 18 electrons. So it would be 6, 1, 8, and option D is nothing but 4D it is. L is equal to 2, azimuthal quantum number. It is 4D subshell and m is equal to 0 he is mentioning. That means he is saying that this m is equal to 0 means it is only a single orbital he is mentioning. He is not mentioning all orbitals present in d subshell. He is only mentioning a single orbital present in d subshell. That means in a single orbital, we know that there are two electrons possible. So the answer for this option is option B. Okay. So then let us discuss the next question. Four diatomic molecules are listed here. Which of these represent the correct order of their increasing bond order? So, for this question, we need to use the electronic configuration and we know that bond order formula is equal to number of bonding electrons minus number of anti-bonding electrons by 2. That is one way of doing this question. Otherwise, you can do this question like this also. We know that after the total MOT calculations, we know that N2 bond order is 3. N2 contains how many electrons? 14 electrons. So 14 electron species will always have bond order 3. Then 13 electron species will always have bond order 2.5. Then 12 electron species will always have bond order 2. 11 electron species will have always bond order as 1.5 uh, and so and so. Okay. And also 15 electron species will always have bond order 2.5. 16 electron species will have always bond order 2. 17 electron species have bond order 1.5. 18 electron species have bond order 1. So here, according to that, we can just compare the bond orders like that. So let us first start with O2 minus. O2 minus, the number of electrons present in O2 minus is 17 electrons. So since O2 minus contains 17 electrons, the bond order of O2 minus is 1.5. In the same manner, this is one thing we need for answering this question. Then let us go back to NO. NO, the number of electrons present in NO is 15. 15 electrons. Oxygen 8 electrons, nitrogen 7 electrons. So 15 electron species have bond order 2.5. 15 electron species have bond order 2.5. And in the same manner, uh, C2 minus. C2 minus, the number of electrons present in C2 minus is 12 plus 2, 14 electrons. That means in C2 minus, the bond order is 3. 3 is the bond order in C2 minus. So then comes helium 2 plus. Helium 2 plus, the number of electrons present in helium 2 plus is nothing but 2 plus 2, 4, 3 electrons. Three electron species, if you follow the same order, just expand it, you will get the bond order as zero point 0.5. Okay. The bond order, you will get it as zero point 0.5. So order here is out of all species, C2 minus 2 is having largest bond order. Then comes NO, it is having 2.5 bond order. Then comes O2 minus, it is having 1.5 bond order. Then comes helium 2 plus, which is zero point 0.5 as the bond order. So the option is option A. The correct answer is option A. So yeah, this is a trick. You can directly use the MOT configuration also. The sigma 1 is to sigma star 1 is to sort of configuration. But you can use this trick to solve this problem much quickly. Then comes the next question. It is based on the physical properties of alkyl halides. So dipole moment of all these types of alkyl halides, fluorides, methyl fluoride, methyl chloride, methyl bromide, and methyl iodide. So basically, what is the answer for this question? The answer for this question would be option D, because dipole moment generally depends on two factors. Dipole moment depends on two factors, that is electronegativity and also bond length. Electronegative atom, the more the ability to polarize the bond, the more the ability to attract the shared pair of electrons, creating positive and negative dipoles. Also, bond length is also one factor which affects the dipole moment. Bond length also affects dipole moment. As we know that dipole moment formula is nothing but charge into distance. So the distance, that means the displacement, that is the distance between the two poles, basically here positive pole and the negative pole. It also is affecting the value of the dipole moment. That's why in case of fluorine, carbon fluorine bond and carbon chlorine bond, if you compare, here since carbon fluorine bond is very short, very small, whereas carbon chlorine bond is pretty longer. Okay, so comparatively longer it is. Since it is comparatively longer than carbon fluorine bond, and the electronegativity difference of fluorine and chlorine is also not so much. Fluorine electronegativity is 4, and whereas chlorine electronegativity value is nothing but it is 3.5, whereas the bond length of carbon fluorine and carbon chlorine is different. I'm sorry. Okay. So that is question number 54. That's why the option will be option D. Generally, if you compare the electronegativities, you will get option A as the answer, but only in case of carbon fluorine and carbon chlorine bond, because of the bond length, carbon chlorine bond attains more dipole moment over carbon fluorine bond. Others are not affected by this bond length order. Then the next question. Next question, what is happening? B2H6, H2O2, OH minus. In this question, in presence of, this is oxidative hydroboration. In oxidative hydroboration, whenever alkynes upon oxidative hydroboration, they will give you aldehydes as the product. Aldehydes or sometimes ketones as the product. Generally, you know that hydroboration follows anti-Markovnikov's rule. So the alcohol group, OH group, is added to the terminal carbon in diborane. Generally, that is less substituted carbons. That means your OH group is added to the corner carbon here, and one of the double bond is broken, OH and H. This is what happens whenever oxidative hydroboration happens. And this enol, you can call it as an enol. It undergoes tautomerism. It undergoes tautomerism to form a ketone sort of product. Yeah, I'm sorry. CH2, C double bond H. This is what is happening in case of hydroboration in the first step. In the second step, the CH3NH2. CH3NH2 acts as a nucleophile, and this intermediate, that is X, it undergoes nucleophilic addition reaction. That means this upon reaction with CH3NH2, NH2 reacts with the carbonyl group because nitrogen is having lone pair. It acts as a nucleophile and it undergoes nucleophilic addition reaction. And the final product after nucleophilic addition reaction is CH2, COH. Alcohol is formed. Then NH2, CH2 is formed. CH3. This is what is formed in this case after nucleophilic addition reaction. So upon heating, when you heat this, what happens is it simply water molecule is eliminated, dehydration, it simply undergoes dehydration, and upon reduction after dehydration. So here what is happening? Dehydration is happening. Alpha beta elimination simply. Alpha beta elimination when it undergoes C double bond C, C double bond C, NH. I'm sorry, 1 minute. Okay. So yeah. So what is happening here? Dehydration happens. So here CH double bond C NH2 CH3 is formed upon heating. This is what happens upon heating. So this upon reaction with H2 in presence of nickel, this means simple reduction, double bonds are broken, simply two hydrogens are replacing the double bond. You will simply get the product as CH2, CH2, NH2, CH3. This is what is formed in the reaction. So according to that, the option would be option B. Okay, option B would be the answer. Okay, so first step, in the first step, it is nothing but anti-Markovnikov's rule. OH group is being added to the less substituted carbon. It undergoes tautomerism. And then when a nucleophile like RNH2 sort of is added to this aldehyde group, it undergoes nucleophilic addition reaction, after which the aldehyde is converted to alcohol. And upon heating, this alcohol undergoes dehydration, and upon reduction of that particular alkene which is formed, you will get a straight chain alkane, and there is a secondary amine in this. So yeah, 56th question. 56th question. You can look at the 56th question. Glucose upon reactant with HCl. What is the structure of glucose? First thing, glucose structure. Let us draw it in Fischer projection. Glucose structure is, you have, it is nothing but aldohexose, right? Biomolecule sort of question it is. So you have Fischer projection of glucose like this. So you have OH, H, and here the configuration is like this: hydrogen OH and CH2OH. And here you have an aldehyde group basically. I'm sorry, give me a minute. Yeah, C double bond O H. This is what is happening here. And to this sort of compound, what are we adding? Hydrogen cyanide, which is a nucleophile basically. Simply, it undergoes nucleophilic addition reaction because there is an aldehyde group. And here, what is happening? Cyanohydrine is formed. So, what is the product? Cyanohydrine is formed in the product. So, as it is, all are as it is, nothing changes. Only the carbonyl group reacts, others all remain as it is. and you get cyanohydrine as the product CHOH and CN, C triple bond, and you will have, and yeah, this is what is formed. It is cyanohydrine. Then, upon hydrolysis, cyanide upon hydrolysis generally gives carboxylic acid. All these triple bonds are broken. All three bonds between carbon and nitrogen are broken, and ammonia is released, and carboxylic acid is released in that case. So, what is happening here? Here, upon hydrolysis, cyanohydrine, you will get a seven-membered chain this time instead of a six-membered chain. So CH2OH, 3, 4, CHOH, and COOH you will get. COOH. Hydrogen, OH group, OH group and hydrogen, hydrogen OH and hydrogen OH. Seven-membered chain. Seven-membered chain is formed. Uh, then what is happening is you are making this entire compound react with HI, which is a reducing agent, which is a very good reducing agent. It can reduce alcohols into alkanes. It reduces alcohols into alkanes, but it can't reduce carboxylic acid. So what is happening here? So here you will get heptanoic acid as the product, except for the COOH. What is happening? All other groups are reduced. Yeah, CH3, hydrogen, 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 hydrogen. A straight chain, acid is formed. 1, 2, 3, 4, 5, 6, and 7. That is nothing but heptanoic acid. Why an extra carbon? Glucose is generally six-membered compound. The extra carbon is added because of cyanide. Cyanide में से carbon जो भी है, that carbon is actually this carboxylic acid. It has turned into the carboxylic acid. So that is heptanoic acid. The answer would be heptanoic acid. Then question number 57. Which pair represents isostructural species? CH3 minus, CH3 plus, NH4 plus and NH3, SO4 2 minus, BF4 minus, NH2 minus and BF2. Option A, so we know carbanion and carbocation. Carbocation, the structure is planar, whereas carbanion, the structure is, what is the structure of carbanion? Carbanion, the structure is pyramidal. That is the structure of carbanion. Then option B, NH4 plus is tetrahedral. Why is it tetrahedral? Four bond pairs, no lone pairs. Total hybridization number 4. sp3 hybridization. sp3 hybridization without lone pairs, tetrahedral will be the structure. Ammonia. Ammonia will have one lone pair. Ammonia will have one lone pair. How to find lone pairs? Number of lone pairs is nothing but valence electrons minus number of bonds divided by 2. Then you will get number of lone pairs in any molecule. So in ammonia, there are nothing but one lone pair. So it is also sp3 hybridized nitrogen only. But the thing is, it will have pyramidal structure. It will have pyramidal. It will have tetrahedral. So both are not isostructural. Then option C, SO4 minus 2, BF4 minus. If you calculate the things like this using this formula only, you will understand that SO4 2 minus structure is like this. Two oxygens have a single double bond, sorry, a single negative charge, and two oxygens would form double bonds with sulfur. It is a tetrahedral structure because two pi bonds are not counted in hybridization. Whereas BF4 minus, even BF4 minus is also tetrahedral in nature. Overall charge, it would have minus. This is also tetrahedral in nature. The option is SO4 minus 2 and BF4 minus. What about option D? Option D, NH2 minus. NH2 minus will, it won't have BEF2 sort of structure. BEF2 structure is linear. Linear. Beryllium doesn't have lone pairs, only two bonds. So it is linear, 180 degrees angle. Whereas NH2 minus is not linear, it is bent. It is having bent shape because there is one negative charge, there is lone pair. So one negative charge is also counted as the pair of electrons. It's like two lone pairs. Two lone pairs and two bond pairs. That means it's like a water molecule structure. That means it is having a bent structure, bent shape, sorry. So the option would be option C. Then question number 58. When the elements lithium, beryllium, and boron are arranged in increasing order of ionization energy, what is the correct order of ionization energy? IE1 we are talking about here. We are talking about IE1. So let us write down the configurations of all of these. And first we need to just remember or recall one statement. In a period, ionization energy increases from left to right. In a period, due to increase in nuclear charge, the ionization energy is also increasing. The more the nuclear charge, the much harder it would be to remove the outermost electron from the valence shell. So, if you follow that order, from left to right, what is the placement of all of these elements? Lithium, beryllium comes in the second group, and boron comes in the 13th group. Boron comes last. So, normal order should be as from left to right, according to the periodic trend, boron, beryllium, lithium should be the order. Boron should have the highest ionization energy. But there is a different order here. Beryllium, in case of beryllium and boron, beryllium is having more ionization energy one than boron. Why? Because look at the configuration of beryllium and boron. Beryllium is having the configuration of 1s2, 2s2, whereas boron is having the configuration of 1s2, 2s2, 2p1. So, here in case of beryllium, we need to remove the outermost electron from a fully filled S subshell from the paired up electrons, whereas boron we need to remove the electron from P subshell basically. That is an unpaired electron, that too. And it is not at all fully filled. So it would be easier to remove an electron from this unsymmetrical type of subshell than where which is it is fully filled. That's why beryllium is having more first ionization energy than boron. So the actual order is lithium greater than less than boron less than beryllium. Beryllium has highest ionization energy than boron, then comes lithium. Increasing order of ionization energy, they asked. That means the answer would be option A. Option A is the answer. That is question number 58. Next, let us discuss question number 59. Atomic radii of fluorine and neon in angstrom units are respectively given by. Here, we don't need to remember the values actually. We can just tell it by comparison. If we know out of fluorine and neon which one is having high atomic radius or which if both of them are having same atomic radius, if we are able to tell that with comparison, we will be able to answer this question. How to do with the comparison? Always remember For fluorine, we generally calculate covalent radius of fluorine. And generally from left to right in a periodic table, from left to right in a periodic table, the radius, the atomic radius decreases from left to right. Atomic radius decreases from left to right as nuclear charge is increasing, effective nuclear charge. That's why atomic radius keep on decreasing, shrinking. So from left to right, if you see, fluorine is having the least radius, but I'm sorry, except left to right in periodic table, atomic radius decreases, except noble gases. This trend is not followed by noble gas elements. Only till fluorine this trend is followed. Noble gases have generally high atomic radius. Noble gases have high atomic radius. So, since noble gases have high atomic radius, why are they having high atomic radius is the question. In case of noble gases, the type of atomic radius they are calculating is the van der Waals radius. And from chemical bonding knowledge, we know that van der Waals radius is generally higher than your normal covalent radius. R van der Waal is greater than R covalent. In case of your fluorine, covalent radius is calculated, which is not smaller than the actual atomic radius. Why? Because in case of covalent radius, the atoms already are overlapping with each other. So whenever you calculate the distance between the nucleus, it is smaller than diameter. That's why covalent radius is smaller than normal atomic radius. Whereas in case of van der Waals radius, both of the atoms are very far, generally far away from each other, and we calculate the distance between both of the nuclei, and our van der Waals radius is that distance by 2. This distance is greater than our actual atomic radius of the element, due to which the size of the van der Waals radius is generally for an element greater than covalent radius. So in case of fluorine and xenon, whatever neon, so it's nothing but the van der Waals radius of neon would be greater than the covalent radius of fluorine, due to which fluorine is having lower radius than neon. So when you compare all of the options, you can see that the second, which is neon, is having more radius in option A than the first. So the option A is the answer in this case. Next, question number 60. The electronic configuration of an element is 1s2, 2s2, 2p6, 3s2, 3p3. From here, you can get an estimate of what element it would be. The valence shell has 5 electrons. That means it is belonging definitely to 15th group number 15. So, since it is the third period and group number 15, in the third period group number 15, you need to remember the positioning. It is the nothing but phosphorus. This element is actually phosphorus. Phosphorus comes under nitrogen, phosphorus, arsenic, antimony, and bismuth. This is the order of 15th group. That means he just wants the atomic number of arsenic. So atomic number of nitrogen is 7. Atomic number of phosphorus is 15. Nothing but it is 7 plus 8 is 15. And here, remember, the magic numbers are in case of P block, entire P block. The magic number order we need to follow is 8, 18, 18, 32, 32 magic number order. That means if you add 8 to your first element of the group, you get the atomic number of the second element. If you add 18 to the second element of the group, you get the atomic number of the third element, like that. So those are the magic numbers which can be followed to find the atomic numbers easily. So 15 plus 18 would be the atomic number of third element present in that group, which is 33. So arsenic atomic number is 33. So that is what we need to know. Next, which pair of symbols identify two elements that are metalloids? This is a conceptual question. You just need to remember the metalloids which are there. You need to just look at the periodic table and remember the metalloids which are having properties between metals and non-metals. Magnesium is a typical metal. Phosphorus is a typical non-metal. Titanium, vanadium, all are D block elements and all D block elements are metals. The major 3D, at least the third 3D series are all metals. Basically, D block elements are metals, so that's why here you through option elimination also you can just answer that question. It is option A. Then question number 62. The electronic configuration of four elements is given below. Arrange these elements in correct order of electron affinity. Just identify what elements are those. 2s to 2p5. What is that element? 2s to 2p5 is second period and it is the valence shell. Since it is the valence shell, it is having 7 electrons. It is fluorine. Then 3s to 3p5. 3s to 3p5 is the element just below fluorine, which would be chlorine. Then 2s to 2p4. It is nothing but 6 electrons in the valence shell. 16th group, second period, it would be oxygen. 3s to 3p4. It's nothing but it's sulfur, the element just below oxygen. So electron affinity order. How to know the electron affinity order? In case of sulfur and oxygen, sulfur is having more electron affinity than oxygen. In the same case of, in the same manner, your electron affinity of chlorine is greater than fluorine. And always remember the electron affinity values of group number 17 are greater than electron affinity values of group number 16. Ability to add electrons. Why 17th group electron affinity is more? Because if 17th, only 17th group elements only need one electron to fulfill their octet. So their electron affinity values, if we are not considering the sign, that will be more than the 16th group elements. So from there, the order would be chlorine greater than fluorine, greater than sulfur, greater than oxygen. So the answer for this option is option B, 2 greater than 1, then 4 greater than 3. That is the answer, option B. Next, the sequence of acidic character in oxides. Always remember two things. One thing is acidic character in oxides depends on two factors. Electronegativity of the atom. The more the electronegative atom it is, the more the acidic character it will exhibit. And then the second thing is oxidation state. These are just some tricks sort of things to solve this sort of question. The higher the oxidation state of the central atom, the higher the acidic character of the oxide is. So here comparing both of them, electronegativity of nitrogen is greater than sulfur. So the oxide of nitrogen would be more acidic than the oxide of sulfur. In case of carbon monoxide and carbon dioxide, carbon monoxide would have more acidic character than carbon dioxide has more acidic character than carbon monoxide because of the higher oxidation state in carbon monoxide, carbon dioxide. So carbon monoxide is having lower acidic nature. It's actually a neutral oxide. If you need to remember this, it's actually a neutral oxide. It's not at all an acidic oxide. Whereas these other three are acidic oxides. So option would be Na N2O5, SO2, CO2, and CO. Option B is the answer. Next question. the correct order of decreasing basic strength among the amines. We need to use our GOC knowledge here. Basic strength is directly proportional to. That means it is generally depending upon the ability to donate the lone pair. And any time if the lone pair is involving in resonance, then the ability to donate the lone pair keeps on decreasing. In all the other options, option 2, 3, and 4, the lone pair is in conjugation with entire benzene ring. The lone pair and the benzene ring form a conjugated system. So there are number of it is involved. It can be involved in the resonance also. That's why in 2, 3, and 4, when compared to the 1, the ability to donate the lone pair decreases in 2, 3, and 4. So obviously, out of all of them, first element, first compound will have higher basic nature. Then how to compare between the other three? How to compare between the other three is always remember basic character increases in presence of donating groups, or you can say plus some sort of groups. Donating groups, in the presence of donating groups, the basic character increases because these donating groups further enhance the electron density in the entire system. Because of the increasing in electron density, the nitrogen would be able to donate the electrons much more easily. That's why here out of all the options, option 2 will have the least basic nature because option 2, this NO2 group is basically electron withdrawing group. It will further depreciate or decrease the electron density in the ring, due to which the nitrogen won't be able to donate the lone pair that easily. That's why the first would be highest basic nature would be 1. Next highest, the lowest basic nature would be 2. Lowest basic nature would be 2. Then comes option 3 and option 4. Option 3 and option 4. Then out of 3 and 2, out of 3 and 4, sorry, out of 3 and 4, the third one, the third molecule would have more basic nature than the fourth molecule. Because in the third molecule, the nitrogen is directly linked to a donating group. Directly, it is linked to a methyl group, which is a donating group. Since these donating group further enhances the lone pair donating ability of nitrogen, this nitrogen would be able to donate electrons easier. Whereas in the fourth one, the donating group is a little bit far away. It would increase the electron density, but is not directly linked to nitrogen. That's why in case of 4, the electron density or the donating ability of nitrogen is lower than in case of 3. So the option would be option A. Then next question. It is about biomolecules. Zwitter ion it is about. So what is happening here? Which of the following molecules will predominate at pH 1.0? That means acidic pH. Generally, at an isoelectric point, we know that these amino acids exist as Zwitter ions. Zwitter ions are nothing but these amino acids, they exist like this. RNH3 plus and the COO minus. This is the Zwitter ion at isoelectric point. So here, if you decrease the pH below isoelectric point, that means in acidic medium. Acidic medium, acid produces H plus ion in the aqueous solution. This H plus ion reacts with this bitter ion to form this sort of molecule. The carboxylate group. The carboxylate group reacts with the hydrogen to form carboxylic acid, whereas NH3 plus remains as it is. So option A would be the answer. In case of basic nature, if you increase the pH, what will happen? Instead of the carboxylate ion, this NH3 plus ion, whatever proton is linked to the NH3 plus ion, that will react and different type of ion is found over there. NH2, CH, COO minus is found. Here, this is the thing which is found. Option A is the answer. Then question number 66. It is atomic structure related question. De Broglie wavelength as a function of kinetic energy. You must know this formula where lambda is equal to h by under root 2 into m into kinetic energy. This is one formula for de Broglie wavelength. De Broglie wavelength, one more formula which we need to remember. H by under root 2 mke. So, here the graph is between lambda and 1 by root 2 mke. So, lambda is the y-axis and let us write it in a different manner. H by under root 2 into mass into 1 by root ke. So this is the x-axis and this is the y-axis. And the slope is h by under root 2m. That means your slope of the graph is inversely proportional to 1 by 2 into mass. That means the more the mass, the lower the slope. The less the mass, the more the mass, the lower the slope. The less the mass, the higher the slope. Slope of B is here clearly slope of B is greater than slope of A. Since slope of B is greater, mass of B would be lesser than mass of A. So mass of A is greater than mass of B in this question. Option C is the answer. Then question number 67. If uncertainties in measurement of position and momentum of a microscopic object of mass m are equal, then the uncertainty in measurement of velocity is given by the expression. So in this question, delta P into delta X, we need to use Heisenberg's uncertainty principle is greater than h by 4 pi. And they are saying both are equal. Both are equal, uncertainty in position and momentum. So I'll just substitute delta X in place of delta P is greater than or equal to h by 4 pi. So delta X square is greater than h by 4 pi. So delta X is equal to, yeah, you can just calculate it as under root h by 4 pi. That means that is also equal to delta P. We know that delta P is equal to m into delta V, which is the value we got it is h by 4 pi under root. So they need uncertainty in velocity. Delta V is equal to under root h by 4 pi into 1 by m. That is the change or sorry, uncertainty in velocity. So answer is option B. Then the next question. So I just had like all the figures from your NCRT textbook pasted here to make it easier. So here this is a match the following directly from the textbook. It is a theoretical question entirely. Sucrose, maltose, lactose, and cellulose. You just need to know what they are made up of. Then you can easily answer this question. Sucrose is made up of a unit of glucose and fructose. So this is sucrose here. And you can see that here there is 1 comma 2 glycosidic linkage. 1 comma 2 glycosidic linkage in case of sucrose. So for option A in list 1, the correct option is option 3. For A it is 3. So for A it is 3. Then for B, maltose. Maltose consists of 2 units of glucose, alpha glucose. 2 units of alpha glucose. That means 2 of alpha glucose, and it will have, this is maltose here, the top one. It has a 1, comma 4 glycosidic linkage. This is the structure of alpha glucose. Two alpha glucoses are there linked to each other. To 1, comma 4 linkage in case of maltose. So B is option 2, A is option 3. Then C. C is nothing but lactose. Lactose is made up of a unit of galactose and a unit of glucose. Lactose is made up of a unit of galactose. So look for the option where there is a galactose. So C is option 1, C is option 1, B is option 2, C is option 1. Then D, cellulose. Cellulose is a polymer. It is a polysaccharide. It is a polysaccharide of beta glucose. It is a polymer of beta glucose. So it is having beta 1, comma 4 linkage between glucose units. So D option would be 1. D option would be 4, I'm sorry. C option would be 1. So option B is the answer for question number 68. Then question number 69. The energy required to break 1 mole of chlorine-chlorine bonds in chlorine is 242 kilojoule per mole, the longest wavelength of light capable of breaking a single chlorine-chlorine bond is. So what is the energy required to break 1 mole of chlorine-chlorine bonds in Cl2? 242 kilojoule per mole, which is nothing but 242 into 10 cube joule per mole. So we have a formula, N into H into C by lambda is equal to 242 into 10 cube. N is nothing but here 1 mole they took. 1 mole of chlorine they took. That means Avogadro number of chlorines. That means 6.023 into 10 cube 10 power 23 is N. And H is nothing but 6.626 Planck's constant into 10 power minus 34 into 3 into 10 power 8 is speed of light divided by lambda is equal to 242 into 10 cube. Here we need to just find the lambda with this calculation. The calculation part is the risky part. 6.626 into 3 into 10 power 23 plus 8 is 31. 10 power minus 3 it would be 2.42 into 10 power 5. I am writing it as. So it's nothing but it's like this 6.023 into 3 into 6.626 by 2.42 into 10 power minus 8. So this will turn out to be 494 into 10 power minus 9 meters. It's nothing but 494 nanometer. 494 nanometer is the answer for this question. The wavelength of two photons. Next question is wavelength of two photons A and B are 100 angstrom and 100 nanometer. The ratio of their energies will be lambda wavelength of two photons lambda A is nothing but 100 angstrom, that means 100 into 10 power minus 10 meters. Lambda B is 100 into 10 power minus 9 meters. Energies EA by EB is nothing but HC by lambda A by HC by lambda B HC get cancelled. It is lambda B by lambda A. It's nothing but 100 into 10 power minus 9 by 100 into 10 power minus 10. It's nothing but it is equal to 10. So EA is to EB is equal to 10 is to 1. So the answer would be 10 is to 1 for this question. Then question number 71. From here we are going to discuss numerical questions. So find out the number of waves made by a Bohr electron in one complete revolution in its third orbit. Simply use Bohr's formula, de Broglie's wavelength h by mv, lambda de Broglie's, and mbr is equal to nh by 2 pi is Bohr's and angular momentum of nth orbit. So here from here mv is equal to nh by 2 pi r, you will get it as. So substitute this equation in equation 2. If you substitute equation 1 in equation 2, you will get h by nh into 2 pi r. So 2 pi r is equal to n lambda. We would get it as. That means perimeter of nth Bohr's orbit is equal to n lambda, n times the number of waves. So perimeter, he's asking one complete revolution. That means it is equal to perimeter of that orbit. That perimeter of third orbit is 3 lambda. The perimeter of third orbit is 3 lambda. That is, 3 waves are made by a Bohr electron in completing a revolution. That means completing a revolution around the third orbit. That means the answer would be 3 in this case. So next question would be, of following the number of species having 2 and more than 2 electrons in anti-bonding molecular orbital. So we need to check through the configuration. Here, we need to write the configuration of helium 2 plus, B2, O2 minus, N2 minus. So the configurations are like this. For helium 2, it is nothing but sigma 1s2, sigma star 1s2. That's all. So yeah, you have 2 electrons here. You have 2 electrons in the anti-bonding molecular orbital. Here sigma 1 is 2, sigma star 1 is 1. It is only 1 electron here. B2, the configuration is sigma 1 is 2, sigma star 1 is 2, sigma 2 is 2, sigma star 2 is 2, pi 2px 1 equal to pi 2py 1. Here how many electrons are there? An anti-bonding molecular orbital. Here there are 4 electrons in anti-bonding molecular orbital. Then the look at O2 minus. Look at O2 minus and N2 minus. In O2 minus and N2 minus, if you write down the configuration, sigma 1 is 2, sigma star 1 is 2, sigma 2 is 2, sigma star 2 is 2, sigma 2px2, sorry, sigma 2pz2, pi 2px equal to pi 2py 2, then pi star 2px2 equal to pi star to py1, simply greater than 2 electrons it is having in anti-bonding molecular orbitals. Similarly, N2, if you write, you will get that greater than 2 electrons are there in anti-bonding molecular orbitals, even in N2. So, only except helium 2 plus All others are having two or more electrons in antibonding molecular orbitals. So the option would be, the answer would be 4. Then question number 73. What is the maximum number of electrons in an atom that can have the quantum numbers n is equal to 4 and m is equal to 1? M is equal to 4 and n is equal to m is equal to 1 and n is equal to 4. We know that fourth shell contains 4s, 4p, 4d and 4f. 4s में m is equal to plus 1 is not possible. Magnetic quantum number is not possible plus 1. In 4p, there is one orbital having m is equal to plus 1. In 4d, there is one orbital having m is equal to plus 1. In 4f, there is one orbital having m is equal to plus 1. Why? Because the magnitude of magnetic quantum numbers ranges from minus L to plus L. Here L is 1, minus 1, 0, plus 1 are the possible magnetic quantum numbers for 4p. 4d it is minus 2, minus 1, 0, plus 1 and plus 2 are the possible magnetic quantum numbers. 4f it is minus 3, minus 2, minus 1, 0, plus 1, plus 2 and plus 3 are the possible. So here each orbital, one orbital has plus 1 as its quantum number. And each orbital have two electrons. Each orbital has two electrons. So total how many electrons contain the magnetic quantum number as plus 1? That is 2 plus 2 plus 2. 2 electrons in 4p, 2 electrons in 4d and 2 electrons in 4f. Total 6 electrons are having the magnetic quantum number plus 1. So answer for this question would be 6. Question number 74. In question number 74, number of chiral centers in B they are asking. So in case of cyanide, here cyanide, the carbon itself is an electrophilic carbon in cyanide. So whenever Grignard reagent reacts with this carbon, what is the product formed here? CH, CH3, C triple bond N. Upon reaction with Grignard reagent, R minus attacks that particular electrophilic carbon, and upon hydrolysis after this step, the formed product would be the formed product would be the ammonia gets eliminated. Instead of ammonia, there will be CHOH. Alcohol is formed instead of ammonia. I'm sorry, ketone is formed instead of ammonia. And there would be, this is the product which is formed in this case after hydrolysis. So the product A, this is the product A. To this product A, again this is reacting with one more mole of Grignard reagent, this time a different sort of Grignard reagent. Again this Grignard reagent reacts with that carbonyl carbon and here bond is shifted onto oxygen and here a tertiary alcohol group is formed in the end. In the end, what is formed? Tertiary alcohol group is formed. C, C2H5, CH3OH. Because the CH3 has attacked the group, so the aldehyde ketone has become alcohol, tertiary alcohol. It's like a nucleophilic addition reaction. It is a. So here, how many chiral centers are there in this carbon? How many chiral centers are there? As you can see here, what all are the chiral centers? This is a chiral center here. This is a chiral center here. And then what others are the chiral centers? Is this a chiral center? Yes, this is also a chiral center. What about this one? Is this a chiral center? Yes, this is also a chiral center. So there are four chiral centers in this compound. There are four chiral centers in this compound. That's why the option would be four. Then the last question of this discussion is a proton and a lithium nucleus are accelerated by the same potential, acceleration potential. Lambda lithium and lambda p denote de Broglie wavelengths of lithium plus 3 and proton respectively. Then the value of lambda lithium by lambda proton is x into 10 power minus 1. The value of x is what? So you have to remember one more formula here. Lambda de Broglie is equal to h by under root 2 into m into q into v, where q is the charge, where q is the charge on your particular particle, whereas v is nothing but stopping potential. V is nothing but the stopping potential. So here, this is one more de Broglie wavelength formula. So we need to use this formula and calculate this question. For lithium plus 3, lambda de Broglie is equal to h by under root 2 into mass of lithium plus 3 into q of lithium plus 3 into v. V is the same they have told in the question. In the same manner, lambda proton is equal to h by under root 2 into mass of proton, charge of proton into v. So lambda lithium plus 3 by lambda t is equal to under root 2 into m proton into q proton into v divided by 2 into m lithium into q lithium into v. The v and 2 get cancelled, and you need to just calculate mass of proton. Charge of proton is nothing but it is 1 unit, let us say. 1 unit charge of proton is. If charge of proton is 1 unit, then charge of lithium would be thrice of that. And mass of lithium they have given as 8.3 into mass of proton. So here these all get cancelled and we will get the calculation as 8.3 into 3. It is around 24.9. Almost it is 25. So it is nothing but 1 by 5 you will get the answer as. 1 by 5 is nothing but 0.2. It is 2 into 10 power minus 1. So the answer here is 2. Value of x is 2. So that is the answer. So yeah, thank you for having this discussion. So thank you once again and please analyze the questions accordingly. All the best for your next exam.